Hello, and welcome. Today, we're exploring a powerful technique used to keep our world safe: magnetic particle inspection. First, let's understand the field it belongs to: non-destructive testing, or NDT. NDT is a science dedicated to examining a part or material without damaging it or affecting its ability to be used in the future. Think of it as a science dedicated to finding hidden problems to prevent accidents and save lives. Magnetic particle testing, often called MPT, is one of the oldest and most widely used NDT methods. It is an indispensable tool for locating surface and near-surface discontinuities, or flaws, in specific types of materials. Its purpose is to reveal hidden discontinuities that could otherwise compromise the safety and reliability of everything from bridges to aircraft. Why is finding these tiny flaws so important? The number one reason is safety. By detecting discontinuities early, MPT helps prevent accidents, avoid catastrophic failures, and ultimately save human lives. The public's demand for greater safety has been a strong force in the development and use of non-destructive tests. Modern engineering also puts incredible stress on materials. Designers often reduce weight or lower the safety factor to improve performance, which subjects parts to higher loads than ever before. A tiny, invisible fatigue crack in an aircraft component or a structural weld on a bridge could lead to disaster. MPT is one of the essential tools used by manufacturers and inspectors to ensure product integrity and reliability. It also helps control manufacturing processes and lowers costs by identifying defective parts before they are put into service, preventing expensive failures down the line. The science behind MPT is rooted in fundamental magnetism. A critical point to remember is that this method only works on ferromagnetic materials, that is, materials that can be strongly magnetized, like iron and most steels. It is not suitable for materials like aluminum, copper, or plastics. Inside every piece of ferromagnetic material are millions of tiny, magnetically saturated regions called magnetic domains. In an unmagnetized part, these domains are randomly oriented, so their magnetic forces cancel each other out. However, when we apply an external magnetic field, these domains attempt to align themselves parallel with that field, causing the entire part to act as a magnet. This temporary magnet has poles, a north and a south, where the magnetic force is concentrated. We can visualize this force as invisible lines of force that form continuous loops, traveling from the North Pole to the South Pole. Here's how we use that magnetism to find flaws. In a sound, magnetized part, the magnetic lines of force flow through the material undisturbed, much like a current in a closed circuit. Now imagine that flow encounters a discontinuity, like a crack. The air inside the crack is much more resistant to magnetism than the metal is, so the magnetic flux cannot easily jump across it. This forces some of the magnetic field to detour. It leaks out of the part's surface, travels through the air to get around the flaw, and re-enters the part on the other side. This phenomenon is called a magnetic flux leakage field. This leakage field creates tiny, localized magnetic poles, a north and south pole, on the surface of the part, right at the edges of the discontinuity. It's important to understand that MPT is actually a form of flux leakage testing. The particles are just the means of seeing the result. This is where the particles in magnetic particle testing come into play. After the part has been magnetized and the leakage fields have formed, we apply finely divided ferromagnetic particles over the surface. Because these particles are magnetic themselves, they are attracted to and held by the flux leakage field created by the discontinuity. The particles will gather and cluster directly over the flaw, building up to form a visible indication. This indication provides a clear outline of the discontinuity's location, size, and shape, making something that was completely invisible to the naked eye suddenly easy to see. The particles can be applied in two main ways: as a dry powder or as a wet suspension, where they are mixed in a liquid like water or oil. To improve visibility, the particles are often colored to contrast with the test surface, or are coated with a fluorescent pigment that glows brightly under ultraviolet light. To get a clear indication, there is one critical rule. The magnetic field must be oriented perpendicular to the discontinuity. A magnetic field running parallel to a crack will not create a strong leakage field, and the flaw could be missed entirely. Since we don't know which way flaws might be oriented, we must magnetize the part in at least two different directions, roughly 90 degrees apart. To find flaws running lengthwise along a part, we use circular magnetization. This is achieved by passing an electric current directly through the test object. This creates a magnetic field that flows in circles inside the part, perfectly positioned to detect longitudinal cracks. To find flaws running across the part's width, we use longitudinal magnetization. This is typically done by placing the part inside a current-carrying coil. The coil induces a magnetic field that runs lengthwise through the part, from end to end, making it ideal for detecting transverse cracks. The equipment used for MPT is designed to handle parts of all shapes and sizes. For production testing in a workshop, the most common system is a stationary wet horizontal unit. This machine consists of a headstock and tailstock that clamp the part and pass current through it for circular magnetization. A movable coil can also slide over the part to provide longitudinal magnetization. These units typically include a tank and pump system to apply the wet particle suspension. For inspecting objects that are too large or heavy to be brought to a stationary machine, inspectors use mobile units or power packs. These are powerful, transportable electrical sources that deliver high amperage current through heavy cables. Using accessories like clamps or by wrapping the cables to form a coil, these units can magnetize massive components like large castings, forgings, or structures on site. For inspections out in the field, even more portable equipment is required. These portable units are compact, lightweight, and can be carried by hand directly to the test site. They are perfect for applications like inspecting structural welds on a bridge or building. The most common piece of portable equipment is the handheld yoke. A yoke is a U-shaped electromagnet. When its legs or poles are placed on a ferromagnetic surface and energized, it induces a longitudinal magnetic field in the area between them. Another tool used with portable power sources are prods. These are handheld copper-tipped electrodes that pass current through a localized area to create a circular magnetic field. While effective, prods must be used with great care to avoid creating arc strikes, small electrical burns on the part's surface that can cause damage. For this reason, prods are not permitted on finished aerospace components. MPT is a cornerstone of safety and quality control across many essential industries. In the aerospace industry, it is used to inspect critical flight components like landing gear, engine parts, and structural mounts for fatigue cracks. The chemical and petroleum industries rely on MPT to check the integrity of welds on pipelines, pressure vessels, and storage tanks, helping to prevent dangerous leaks and environmental incidents. In electric power generation, it is used to inspect high-stress components like steam turbine blades, rotors, boilers, and piping for cracks caused by extreme temperatures and stress. For infrastructure, MPT ensures the safety of our bridges and buildings by verifying the quality of critical welds in their steel structures. And in everyday manufacturing, it is a key quality control tool for countless parts, including automotive crankshafts, industrial forgings, and castings, ensuring they meet their design requirements. In summary, magnetic particle testing is a highly effective method for finding surface and near-surface flaws in ferromagnetic materials. Its primary advantages include its sensitivity to small cracks, its speed, and its relatively low cost. It is also highly versatile, applicable to parts with complex shapes, and can be performed easily in the field with portable equipment. However, it is crucial to remember the limitations. The most significant is that MPT only works on ferromagnetic materials. The magnetic field must be oriented correctly relative to the flaw, requiring magnetization in at least two directions. The part's shape or surface condition can sometimes interfere with the test. Finally, parts often need to be demagnetized after inspection, and improper technique can cause surface damage like arc strikes. Despite these limitations, MPT remains an essential non-destructive testing method, helping to create a safer world by making hidden hazards visible. To help technicians prepare for their general exams, we're excited to announce that the AMS Level 3 NDT Test Prep app is now available in the Apple App Store. This app is built to help NDT technicians at every stage, with NDT questions for Level 1, Level 2, and Level 3 general exams. You can choose between two modes of learning: study mode, answer questions, get instant feedback, and read clear explanations of why the answer is correct. Test mode. Simulate a real NDT general exam to see how you would score under actual testing conditions. Whether you're preparing for certification or sharpening your knowledge, this app gives you the tools to succeed. Download it today in the Apple App Store and take the next step in your NDT career. Thanks for watching today's video from AMS Level 3. Our mission is to support your success with expert Level 3 consulting, NDT training and mentorship, and full compliance solutions for NADCAP, FAA, and ISO audits. A special shout out to Skaggs Media, LLC, for producing today's video. Skaggs Media specializes in helping businesses build a strong presence on social media through creative video, photography, and digital content. Check them out at skaggsmedia.com. Don't miss out on more practical insights. Subscribe to our YouTube channel for in-depth podcasts, training videos, and career development tips for NDT professionals. If you found this video helpful, give it a like, share it with your team, and hit that subscribe button. Together, we can strengthen the next generation of NDT excellence.